Hi, good morning everyone. My name is Hardik Kumar. I will presentation about bike rental count, a data approach on the subject of business analytics. This is first like introduction. In this project, we applied business analytics techniques to real-world dataset on bike rental from the UCI machine learning repository. Our primary tools were Excel for data visualization, descriptive statistics, and multiple regression analysis. The goal was to identify pattern and predict rental demand, which can help optimize bike fleet operations and improve decision making in resource allocations. These dataset include variables such as hour of the day, temperature, humidity, and session, which we used to build our analysis model. Uh, Scope and limitations. And focused on there are three main areas: data processing, including cleaning, feature encoding, and selection; identifying trend and determining feature importance using a p-values; model interpretations and explainability to ensure our findings were unsuitable and actionable. Uh, it's the second one. About dataset, uh, I used the bike sharing dataset from the UCI machine learning repository, which provides real-world data on bike rental. The dataset covered hourly records from 2011 to 2012 with a total of 17,379 observations. It includes 16 variables such as temperature, humidity, hours of the day, session, and more. The main target variables is called CNT, which represent the total number of bike rented per hour. To ensure the clean and used data, I performed several processing steps. First, I removed irrelevant columns like instant, casual, and registered to reduce and avoid data leaking. Then I converted variables to the appropriate data type for accurately analysis. Finally, I used Excel to carry out null checks, feature selection, and data normalizations, ensuring the dataset was ready for further exploration and modeling. And descriptive statistics. I have summarized the key descriptive statistics for several variables in the dataset, including session, year, month, hour, holiday, and weekdays. As I mentioned earlier, the data contains 17,379 hourly records covering the year 2011 and 12. The mean rental hours is around 6.5, with the most frequent hour being 16, indicating high activity in the afternoon. Variables like session and month shows balanced distribution which medians around the middle values. A notable point with the binary values such as holiday and weekdays. This shows high skewness. Holiday is right skewed, meaning the most entire are non-holiday. Weekday is slightly left skewed, which make sense. Most rental happens on weekdays. Descriptive statistic counted. Additional descriptive statistic for these key predictors such as working weatherist, temperature, humidity, wind speed, and target variables bike rental count. The average bike rental count is 189, while the maximum is 976, indicating a high valuation in demand depending on the hour conditions. And other predictor variables like temperature, apparent temperature, humidity, and wind speed shows moderate standard variations, which suggest a relevantly consistent environmental condition across dataset. The variable have been normalized on hourly basis, making uh, them suitable for analysis and regression. Environmental variables appear normally distribution due to processing which improve the effectiveness and model. Overall, the data registered analysis which pattern measurable variations and well-behaved distribution in the key feature. That's all. Have a nice day. Next, please.
Hello, my name is Dikshit Amelia. I'm going to take on presentation from here. So our report shows that like the bike rentals peak during the typical commute hours 7 to 9 a.m. and 5 to 7 p.m. clearly reflecting workdays travel patterns. Seasonally spring and summer see the highest demand while the winters drop off due to the cold weather and the less daylight. Weather plays a big role to a clear days account about 71% of all the rentals. Temperature tends to boost usage while humidity and the wind reduce it. From our model, we found it explains around 67% of the variability in rentals, with key factors being the time of the day, weather conditions, whether it's a working day or even in the year. Overall, it's clear that both environmental comfort and the routine commuting patterns drive demand, which is really useful insight for planning smarter urban mobility systems. So the next slide is for the recommendation. To better align supply with the demand, we recommend increasing fleet availability during peak hours, especially between 7 to 9 a.m. and 5 to 7 p.m. so we can reduce wait times and enhance customer service. Seasonal planning is also key by scaling down operations in winter and ramping up in summer and spring. We can manage cost while still meeting higher demand. Additionally, we should incorporate weather forecast into our demand models on clear and mild days. For example, we can boost usage by offering targeted promotions. Our marketing approach should also adapt to timing, promote commuting solutions during weekdays and leisure rentals on weekends. By making this data driven adjustment, we can improve operational efficiency and significantly increase the customer satisfaction. So for the closing insights, we use the UCI bike rental dataset and analyzed it using Excel tools like regression analysis, data visualization, and some basic statistics. The goal was to understand what drives bike rental demand. We found that key factors including the hours of the day, temperature, humidity, whether it's a working day, and the weather condition. We built a regression model with an R squared value of 0.674, which means the model has a pretty strong ability to predict rental demand. Visualizations also showed clear patterns like higher demand during certain hours and seasons. These insights can be really useful for optimizing bike fleet management and planning resource allocation. Overall, the project shows how valuable business analytics can be in making smarter decisions for urban mobility.